In lesson 4 of compensating wage differentials, we're going to adapt the neoclassical model of the worker that we have been analyzing. Instead of it modeling the trade-off between leisure and consumer goods, we're going to look at what happens when we assume that workers are working full-time, right? We're looking at full-time workers only. So hours worked is given, which means leisure is given. And so workers are going to have a trade-off between non-monetary benefits and wage income. And we're going to look at not the wage rate per hour, but the monthly wage rate. Okay. So workers are going to maximize their utility by choosing jobs. Full-time workers, we should say, full-time workers are going to maximize their utility by choosing jobs based on what the monthly wage rate is, right? And I guess the monetary value of employee benefits, which includes various perks like parking, free coffee and snacks, beautiful office views, modern office designs, and health insurance, right? And other things like retirement benefits, right? So all that stuff is lumped in B. Now, firms are going to attract workers by offering W and B, right? W being the monthly wage rate and B being the value of their benefits package, right? This downward sloping black line is the firm's isoprofit curve. Profits are the same, right? Anywhere along this black line. And what it models is the firm is going to make the same amount of profit, whether it offers a monthly wage rate of just over $6,000 and $0 worth of benefits, or if it offers the opposite, over $6,000 in benefits and 0 monthly wage, or any combination in between on this black line, right? So that's the isoprofit line. Anywhere along it, the cost of hiring workers equals the marginal revenue product of labor of those employees. At point X, employee benefits cost what? Benefits are 0, right? And wage income, let me hit enter here. When employee benefits are 0, according to this isoprofit line, the monthly wage rate is $6,100 per month, right? Per employee. All right. At point Y, employee benefits cost $2,440, right? $2,440 a month. And let me hit enter to get the wage income. The wage income is $3,660, right? Okay. Now, if I add these two together, I get 6,100, right? At point X. If I add these two together, I get 6,100. 60 plus 40 is 100. Carry the 1. 6 plus 1 is 7. Plus 4 is 11, right? Carry the 1. 3 plus 2 plus 1 is 6. So this pair equals 6,100, and this pair equals 6,100. So since the economic profit generated by each of these employees, whether it's type X employee or a type Y employee, each employee's marginal revenue product of labor equals $6,100 per month, right? Okay, so the red indifference curve is tangent to this black dot, X. The blue indifference curve is tangent to this isoprofit line at point Y. This is type Y's indifference curve that is tangent to the isoprofit line. This red indifference curve is the indifference curve of type X, and it's tangent to the black isoprofit line at point X, right? Now, there are infinite many red indifference curves, right? I'm just showing you one. And there's infinite many blue indifference curves. And again, I'm just showing you one, right? So this is an optimal choice for type X employees. And this is a optimal choice for type Y employees, right? Type Y employees are looking for companies that offer both wage income and benefits. Type X employees are only looking for jobs at companies that offer just wage income and no benefits, right? Now, I was a type X employee when I first got my PhD and I got my first teaching job. I went to employee orientation at my first teaching job with the Human Resource Department. My first question was, can I forego all benefits to get us a higher salary? And they said I couldn't. So I would have chosen that because I figured I'll keep myself healthy. I'll eat right. I'll get exercise. I don't need retirement because I'll save myself. I want the freedom to save myself because I wanted to maybe buy rental properties instead. And I was going to stay healthy. So any money I would get from the benefits, I wanted to convert that into higher salary, right? So there are people like that. I think most people like some benefits, but I think most people want mostly a monetary wage, right? Okay, so the indifference curves that were inserted in the above graph indicate the presence of two categories of workers. We have type X workers, as I mentioned, right? And then we have type Y workers. And the preferences are modeled by these indifference curves, right? Again, there's infinite many of these blue ones, and there's infinite many of these red ones. The red ones never intersect. A red indifference curve will never intersect another red indifference curve. This blue indifference curves don't intersect blue indifference curves. So the blue indifference curves are going to look like a stack of bowls, right? A stack of bowls. Same with the red indifference curves, right? But the red and blue can intersect because they're two different kinds of people. These indifference curves bend toward the origin because all of them consider wage income and employee benefits as goods that are imperfect substitutes. If they were perfect complements, you'd have a line. If they're perfect substitutes, they would be L-shaped, right? So these are imperfect substitutes. Type X and type Y must be equally productive workers because the combination of W and B offered to each are points along the same isoprofit line, right? And the values of this employment package equals the value of this employment package, right? So since the indifference curves imply that type Y has a balanced preference for employee benefits and consumption, and type X leans significantly toward a preference for consumption over employee benefits, type X workers accept positions with employers who offer them a wage equal to $6,100 a month and employee benefits worth $0. While type Y workers accept positions with employers who offer them a wage income equal to $3,660 per month and benefits worth $2,440, right, a month. Okay. In the above example, we cannot observe these worker preferences. We don't observe the blue indifference curves. We don't observe the red indifference curves. What we observe is the black dots, right? we observe the black dots. And the black dots say there's a trade-off between wages and benefits, right? So I'm going to reinsert the information here. This is $6,100, right, for type X workers, and the benefits are worth 0. And then for type Y workers, the wage income is $3,660, while the benefits are valued at $2,440, right? Okay, so what we want to do here, again, we can't observe the workers' preferences, the indifference curves. We observe whether they are working or not. We observe their wage income, and we can observe their benefit packages, right? We can also use economic theory and statistics to estimate the monetary value of the employee benefits, right? Assume that it is where we got the above dollar values. Using this information, complete the table below. I'm going to replicate this table in Excel. I got 6,100 there. I got 0 here. 2,440 there. And I don't know if these are high productive workers or not, right? And it wants me to calculate the coefficient of determination, R square, between W and B, and the correlation of W and B, right? To calculate the correlation of W and B, all we have to do is type equal core roll. And then I can grab those two numbers and then hit a comma. That's the variable B. Now I want to get the variable W, right? And then I can hit parentheses and hit enter. Well, the correlation is -1, right? Correlation is -1. To get the R square, I can either square this, which would be 1, or I can highlight the 3 columns, click on insert, recommended charts. We'll do that chart, that scatter plot, right? Okay, this scatter plot, let me make it smaller. Okay, I got a point here, and this point corresponds to what? It corresponds to the type B, or the type Y worker, right? The type Y worker. And this point down here corresponds to the type X worker, right? And then if I right click on one of these dots and add a trend line, I can add the R square at the bottom. Whoops. Let me move this down. I can display the equation and the R square value, right? And you can see the R square value is 1, right? Just as we suspected. So the R square is 1. Okay, suppose a portion of the workers end up being star employees because they are far more productive than their colleagues. So this would mean that there are actually 3 types of workers. We have X-type workers, Z-type workers, or Y-type workers, and Z-type workers. Z-type workers find jobs where the benefits are valued at $4,560. And their wage income is $6,840. Now, the isoprofit line is further from the origin, so this isoprofit line represents more profit than this one, right? And the reason why that is because the Z-type workers are more productive. The marginal revenue product of labor of each of them equals the sum of these two numbers. 40 and 60 is 100. Carry the 1. So that makes that 9. 9 and 5 is 14. Carry the 1. And then 6 and 1 is 7 plus 4 is 11, right? So the value marginal product of their labor is 11,400. Okay, now we're going to add this new information to the table, but we're going to make this table appear longer. So this was 6,100. And the value of the benefits were 0. And then for the Y-type worker, the value of the benefits was 22,440. And the wage income was 3,660. And both of them were low productivity workers. And then the high productivity worker, type Z employee, their wage income is $6,840, and the value of their benefits is $4,560. Okay. Now we got to find the correlation and the R square of this new table, right? So what I'm going to do is I'm going to insert a row here. I'm going to change this to Z. I'm going to add $6,840 there. And I'm going to add $4,560 there. Then I'm going to click on this correlation here. And I got to pull this down to include the 4,560. I got to pull this down to include the 6,840. When I do that, I get a correlation of 0.182703, right? Now I want this to 4 decimal places, right? 4 decimal places. So let's reduce this to 4 decimal places. 0.1827 is the correlation. And then I got to get the R square, right? And to get the R square, I can just click on a point here. Well, let me delete the trend line. Let me add a point. And you can see visually why the correlation fell so much. Okay. It fell because the correlation collapsed because now we have these 3 dots, right? Is the relationship negative, or is the relationship positive, or is the relationship really positive, right? Okay. Then we can insert a trend line to get the R square, right? We're going to display the R square. And the R square is not very big at all, right? The R square is 0.034334, right? So that relationship fell apart, right? Now, why did it fall apart? Because if we're only looking at type X and Y employees, right, we're going to observe this point and that point, right? Well, then there's a trade-off between monthly wage rate, and benefits. But if we include the Z-type employees in this study, right, something's shifting. This productivity is shifting the isoprofit line out here, right? Okay. So for X and Y type employees, there's a trade-off, right? For Z type employees, relative to X and Y type employees, there is no trade-off between the two variables, monthly wage rate and the value of the benefits, right? Looking at this data very closely reveals about 25% of them look like type X employees because they have jobs with employers who provide low monetary values of employee benefits. 25% of them look like type Z employees because they have substantially higher values of total compensation and employer benefits. And the rest appear to be type Y employees because the total value of their compensation is roughly equal to type X employees. And the value of their employee benefits is substantial. So you've grouped the data using two variables, type and D, right? Here's type right here, and here's D. D is a dummy variable for high productivity workers. Type is a categorical variable that identifies a worker as type X, type Y, or type Z workers. Compute the average, minimum, maximum values for the three types of workers. Given these results, the type groupings seem appropriate because, right? So we got to come up with a reason. So let me do this. Let me grab this table here. Let me grab this table. I'm going to paste it over here. And it looks like 25, we've defined 25 of them as type X, right? We defined 25 of them as type Y. And we define 50 of them, it looks like, as type Z, right? Total compensation here, let me see, let me show you this. I got my sum right there. That's 85 a month, 75 a month, 85 a month, 78 a month, right? What about type Y employees? Well, we're looking at 6,200, 4,600, 4,900. So total compensation for Y and Z, there's definitely some kind of threshold that turns an employee from a Y type employee to a Z type employee, right? All of a sudden, total compensation really jumps, right? From 7,000 to, I don't know, 8 or 9,000. And then down here, 6,000 to maybe 5,000, right? And then Z employees or type X employees have very little, they have very little, the value of their benefits is quite low, right? The value of their benefits is quite low. This actually should be B here, right? Yeah, it should be there. So we have W, B, and D, right? W, B, and D. So the wage, monthly wage, monthly value of benefits, the dummy variable, and the type X. The dummy variable, it's 0 for type X and Y employees, but all of a sudden is 1 for type Z employees, right? Okay. So let's calculate some statistics here to see if these classifications make sense, right? We're going to calculate the minimum. We're going to calculate the minimum for the type X employees. So we'll type equal min, and then I'm going to come over here and grab the wage rates from B17 down to the monthly wage rate for the last type X worker. And the last type X worker is right there, right? See that? That's the last type X worker. I'm gonna copy the cell designations, right? B17 to B41. This is at B41 here, right? Column B, row 41. And then this value is in column B, row 17, right? So I'm going to copy this and I'm going to put it here for the average. So the mean or average for the type X worker is that value. The maximum value, right, for the type X worker, right? And then we do the same thing for the type Y worker. So I need the minimum for the type Y worker. So I'm going to come over here. I'm going to go down and find my first Y worker's wage, right? Monthly wage. I'm going to hit the shift button and I'm going to go to use the down arrow until I get to the last Y worker wage. And it's $4,327.68 per month, right? So I'm going to copy these cells, right? I'm going to copy that. I'm going to use it in my average, right? I'm going to use it in my max. So look at my minimum wage. The lowest wage that a type X worker is 4,600. The maximum monthly wage is almost 6,000. For a type Y worker, we're looking at a minimum of 3,160 and a maximum of 4,327, right? Now let's look at our type Z workers. So again, I need min, right? I'm going to come over here to column B. I'm going to go down until I see my first Z type worker, which is right there, right? In row 67. Then I'll go to the very bottom here. We got 50 of these type of workers, right? And that worker's in row 116. So I'm going to copy this, right? I'm going to copy that. And I'm going to type equal average here. And I'm going to get the max, equal max, right? Okay, so for the type Z worker, the lowest type Z worker wage is 5,000 a month. The highest is 61 a month, right? Now, to get the value of benefits, the summary statistics for the value of benefits, I can just pull this to there, right? So if we add these up, if we add these values up, if we sum them, right? This is the total compensation here. In total compensation, it looks like X and Y, you look at the max and the minimums, right? 4,900 roughly, 6,200. Well, these values are pretty close to these values, right? But all of a sudden, the total compensation of the type Z workers is a lot more than the minimum for the type Z worker is more than the max for the type Y worker and the type X worker, right? So the total compensation is substantially higher for the type Z workers, right? And then the type X workers, they generally have low values of benefits, right? Monetary values for their benefits. They have high wage values, right? Their wage rates are about the same as the type Z, but the value of their benefits are a lot lower, right? So it looks like these are pretty good definitions of the type. It looks like we did a good job of classifying the type of workers and then creating this dummy variable to designate the high productivity workers, right? The high productivity worker is going to get paid a lot. Now, given these results over here, right, the type groupings seem appropriate because why? Well, X's highest B is less than type Y's lowest B, right? That's true. Type Y's highest B is less than type Z's lowest B. And type Y's highest W is less than type Z's lowest W. And the type Z's generally have the highest total compensation, right? We checked that when we summed them, right? So it's all of the above. So these are good. If these were guesses, if these designations were guesses, we did a really good job with them, right? Okay, so now we got to plug in these values here. I'll just copy them one at a time. So the minimum benefit level, right? Okay. And then I'm gonna pause because I'm gonna spare you the copying and pasting. Okay, it looks like we did a great job of getting these summary statistics. Let's just finish them off here. Finish them off. Okay, so on the average, type Z's have a high average monthly wage, it is greater than the type X's, but not by too much, but it's a lot greater than the type Y's, right? And the reason why that is because the type Y's average benefit level is, well, it's not close, but it's it's kind of close relative to the average benefit level of the type X, right? Okay, now we're going to estimate some regression models here. We're going to try and figure out if there's a trade-off or not between wages and benefit levels. So the first regression is a simple regression with the wage rate versus the benefit level. So I'm going to come over here to Excel and I'm going to click on data. Now, when you click on the data tab and you don't see data analysis here, you'll need to do this. You'll have to go to File, click on Options here at the bottom. And then click on Add-ins in this menu, right? And at the bottom here, make sure Excel add-ins is selected. Click Go, and then just make sure Analysis Tool Pack is chosen, check mark, and then hit OK, right? Now I have the Analysis Tool Pack, Data Analysis Tool Pack already included, right? So I'm going to click on Data Analysis. I'm going to click on Regression. So the Y variable is what? The Y variable is W, right? W is on the left-hand side. So I need to load the Y variable. I'm going to include the label W and all the numbers below it. Okay. Then I'm going to load the other column, the benefits column, right? Load the benefits column here. Okay. And then I'm going to click on labels because I included the row that includes the labels, row 16. See that, row 16 and row 16. I'm going to check on output range. And I'm going to put my output, over here. I'm going to put my output in, let's see, I don't want to delete this. So I'll put it out here in J. Okay, I'll put it in K. K1. Okay, then I hit OK. Click OK. All right, so here's my summary output, right? Okay, so what I'm going to do is I'm going to auto fit this stuff. And I need, to 4 decimal places, I need the intercept and the slope. Here's the intercept and here's the slope of my benefit level, right? So I'm going to click on home here, click on number, and then reduce the number of decimal places to 4, right? So my intercept is 4,660.5624. That's my intercept. The slope coefficient of the benefit variable is 0.1973, right? I'm going to hit enter to see if I got it right. And it looks like I did, right? So that's my simple regression. Now the R-square, when you're doing simple regression, when you have only one variable, when you only have one regression variable, right? In my case, B, you want to interpret the R-square, right? And I want to convert it to percent. See that? I want to convert it to percent. So what I'm going to do is I'm going to convert this to percent. I come up here and do a percent, and I want it to 4 decimal places. Okay, so I'm going to copy it. I'm going to copy it, and I'm going to place it right here. Now, because the word percent shows up there, I can delete the percent symbol, right? I'm going to hit enter. Okay, so the R square here implies that 3.88 or to one decimal place, right? To one decimal place, 3.9%, right? So the R square implies that 3.9% of the variation in W, right? So the variation in W here, W varies, and so does B, right? But this simple regression model says that the R square implies only 3.9% of the variation in W is explained by the model, which just is, B, the linear model in B. Okay. Now we're going to estimate model 2. Model 2 includes two variables, B and D. So what I'm going to do is I'm going to come back over here to Excel. Okay. I'm going to redo my regression, but I'm going to define X to be the two variables B and D, right? So I'm going to click on data analysis. I'm going to choose regression, right? This is fine, right? My Y variable is fine. It's still W, right? My Y variable is still W. See that right there, W. But I got X, my matrix X, right? X1 is B and X2 is D. So I got two X's, right? So I'm going to click on this right here so I can add two X's, B and D, right? I want two columns. I want two columns of X variables. The dummy variable that is 1 for high productivity workers, 0 otherwise, and then the benefit level, right? Okay. All right. So I got column C and D loaded from rows 16 to 116. Then all I have to do is hit OK, and that will cover up my results over here, right? There it goes. Okay. All right. So now I got two variables, right? I got the benefit level and I got the dummy variable D, right? Okay. So this is my multiple regression model. When you have two X's, B and D, right? When you have two X's, two or more, you want to interpret the adjusted R square. So I'm going to change this to a percent. And then increase it to 4 decimal places. I'll make it red to have it stand out, right? And then I got my model here, right? This is my model, my linear model. I'll make that red, bold, so it stands out. And then I'll reduce the number of decimal places to 4, right? So now my intercept in my model is $5,281.79, roughly, but I have more precision. The slope of my benefit level is negative, right? That indicates there's a trade-off, correct? And then my dummy variable is 2372, right? 2372. Now look at my p-values over here. Let me reduce them to 4 decimal places. My p-values are all, close to 0, right? My F statistic is massive, right? So what is this saying right here? Let's go back to our chart. Let's go back to the chart here, right? So what this does, it creates two intercepts, right? When D is 0, right? This part is 0 here, right? This box times D is 0, so this is gone. So the intercept would be 5,281, right? 5,281, and we'd have a line that comes down here like this, right? If D is 1, right? If D is 1, then I add this to that. When I add this to that, what that does is it shifts my line up, right? It shifts my line up to here, right? So I have a line coming through here, and I have a line coming through here, right? So you can imagine the line coming through here, and then it's shifting out to here, right? That's what this model's saying. The adjusted R-square was 66.5650%, right? Again, the word percent's right there, so I can delete this percent symbol. It'd be redundant otherwise, right? Okay, so if you're looking just at the R-square, if I was just looking at the R-square, I'd say this model fits the data better than this model, right? Our p-values are all 0, right? So this model fits really well. The p-values for the intercept, the slope, and the dummy variable are all really close to 0. The F statistic is massive, right? Almost 100, right? And that's for our multiple regression. Let me re-estimate the model with just the benefit level, and I'll show you the difference. So let's go back here, and I'll click on the X range again. In the simple regression, we only needed B, right? We only needed B. So this is my Y variables in the column B. I only have one X variable, that's column C. I'll hit OK, and then hit OK here. And you're going to see that we only have one regression variable right now, right? So I forgot to note this earlier, right? So let's look at what's going on here. Let me reduce the number of decimal places to 4, right? See, our p-value here, this is positive, right? And it's significant, right? Positive and significant. So this is significant, not as significant as this and this, right? The p-values for all three of these were zeros, right? The p-value that is 0, but the p-value this is 0.05, right? To 2 decimal places, right? But this is positive and that is negative, right? But the R-square is saying 3.88% of the variation in W right here is explained by this model. That's not very high. This model here, the F statistic is only 3.952, right? In the multiple regression model, the F statistic was 99, right? So I would say model 2 is more significant, right? The p-values were all really close to 0, right? This indicates there's a trade-off. This indicates there's no trade-off. And it's a number close to 0, right? So model 1 suffers from what we call omitted variable bias. We're omitting important information, this dummy variable, right? When we include that dummy variable that indicates or differentiates between the low productivity workers and the high productivity workers, we get a much better fitting model, right? Down here, this adjusted R-square says 66.6% of the variation in W. So 66% of the variation in this W is explained by this model, whereas only 3.8 or 3.9% of the variation in W is explained by that model. So I think we can conclude that this model is preferred to model 1, right? Okay, now we're going to do a new model. And I moved my data up to row 1, right? And then my regression results are over here, right? Okay, so now what does this tell me to do here? Okay, let's go back here. This is why I said put the table in cells A1 to D101, right? So A1 to D101, right? And this is the reason why I asked you to do that. I forgot why I had to do that, right? So we're following that instruction there. Why? Because it says here, right? Type D times B type D times B into cell E1. So I'm just going to write D times B, D times B. And then type 1 minus D times B in F1, right? Okay. So I got this in F1, I got that in E1. Now in cell E2, I'm just going to copy this. In cell E2, we're going to copy that, and we're going to paste it right here inside the cell, right? And that multiplies the value in column C times the value in column D, right? Which is 0. This times that is 0, right? In F2, I'm gonna copy this and put that into F2, right? Right. So what this is doing is it's gonna subtract the 0 from 1, right? So this is 0. 1 minus 0 is 1. And 1 times C2 is C2, right? Okay. And then we're going to double click to copy these formulas all the way down to the bottom there, right? Now, what happens when D turns to 1, right? Now, all of a sudden, these two things, this value here is in column E, and we have 0 in column F, right? Okay. And we're doing that because we're going to estimate a new model down here. We're going to estimate the model with an intercept, a coefficient for the dummy variable, a coefficient for the dummy variable times the benefit level, and 1 minus the dummy variable times the benefit level, right? So this model is going to generate two slopes. It's going to generate two slopes. It's going to generate a slope for type X and Y employees for benefit levels. And it's going to generate a different slope for type Z employees, the high productivity employees, right? Okay, so now we want to estimate this model here, right? So my X matrix, my X's are these three columns, right? That's going to be my new X matrix, right? So let's click on data. Click on data analysis, regression. Okay, so my Y, well, I got to fix this. My Y, let me delete it, is still the W's, right? The W values. That's still my Y right there, right? My X range, my X variables are the dummy variable out to this, the last three columns here, columns D, E, and F, right? And then I'm going to put that in K1. I got my labels chosen, so I can hit OK. Right? Okay, got a new set of regression output. I have three regression X variables, right? Let me insert a column here. Things got a little too cozy here, right? I got my adjusted R square, right? I'm going to convert that into a percent and then 4 decimal places. And then I got my model here, right? We're going to change that to 4 decimal places. Whoops. Okay. These are still highly significant, right? the p-values are really close to zero, right? So these are still highly significant. I have an intercept when the intercept is 5,473, right? When the dummy variable is 0, right? But when the dummy variable is 1, the intercept changes to 3,520, right? Now the slope for high productivity workers is positive. The slope amongst low productivity workers is negative, right? So what this says is there's no trade-off. There's no trade-off between benefits and wages for high productivity workers. This says there is a trade-off between low productivity workers, type X and Y workers, right? And both of these slope coefficients are highly significant. The dummy variable is highly significant, right? Now I'm gonna kind of wrap this up in a scatter plot. You're gonna see it real quick. Okay. All right. So let's fill in our model here. The intercept, right? So when D is 0, the intercept of the model is that. When D is 1, because we're talking about the high productivity workers, the intercept actually becomes, right? We add this to that negative number, the intercept actually falls to 3,520, right? The slope for the high productivity workers is 0.8543. The slope for the low productivity workers is a negative 1.0985, right? So this model is different than this model because this model has one slope coefficient for the benefit level, right? This model has a slope coefficient for the high productivity workers and a slope coefficient for the low productivity workers, right? And in this model, 78.8901% of the variation in W is explained by this model, right? So the R square is better than it is here, right? Also look at the F statistic. The F statistic is massive now. When we had two variables here, right, it was 99 point something. When we had one variable, the F statistic was like 3, right? 3.5 or something. By having two intercepts essentially and two slopes, our F statistic is 124, and all the p-values of the variables are highly significant, right? So I would say model 3 is the best fitting model. We want to find the p-value of D times B, right? The p-value of D times P was what? The p-value of D times B was 0.0007. We can conclude what? Wage income is negatively related to employee benefits. I don't think we could say that because the coefficient is positive, right? So we can conclude that wage income is positively related to employee benefits. We can do that amongst, remember, D is 1 if the employee is high productivity, right? And high productivity workers were type Z workers, right? Z workers. Type Z were the high productivity workers. Right? Okay, what about this coefficient here? This coefficient is negative, and its p-value is 0.000, right? So this coefficient is highly significant, and it's negative, right? When D is 0, we're talking about the low productivity workers, the type X and the type Y workers, right? So when D is 0, this equals 1, right? So we're looking at the benefits, monetary value of the benefits of the type X and Y workers. And amongst them, right, there's a trade-off. There's a trade-off. We're going to conclude that wage income is negatively related to employee benefits amongst X and Y employees, right? X and Y employees, the low productivity workers. When we're talking about X and Y, we're talking about D equals 0. D equals 0 subtracted from 1, well, that's 1. So we're talking about the benefit levels of type X and Y workers, right? So we'll hit enter here.